Hey mathematicians, this is Mrs. Shopper with 12-8 congruent and similar solids. All right, so similar solids, just we know what the idea similar means, but similar solids have the same shape, but not necessarily the same size. All spheres are similar and all cubes are similar. Congruent solids have the same shape and size. So building on our knowledge of similar and congruent, okay? If two solids are similar if they have the same shape and the ratios of their corresponding linear measures are equal. Okay, so again, similar means that their sides are proportional, that their one dimensions are proportional. Their one-dimensional measurements are proportional. Okay, so congruent solids, two solids are congruent if they have all of the following characteristics. Corresponding angles are congruent, corresponding edges are congruent, corresponding faces are congruent, and the volumes are equal, right? So what we need to do is determine if the pair of solids is similar, congruent, or neither. If it's similar, we have to state the scale factor. So when I look at these, they're not going to be congruent because these measurements are not the same. What we need to see is if they're proportional. So is the square root of 7 to 5 square roots of 7 over 2 proportional to 2 square roots of 3 over 5 square roots of 3? Okay, so let's see. We've got, if we do cross products, we've got 5 square roots of 21. And we do cross products here, we have 5 square roots of 21. So far it's looking like they're proportional. Let's see if that holds true for the last remaining side. So if we do cross products here, we're going to end up with 10 square roots of 15, 10 square roots of 15. So these are similar. So now we need to state the scale factor. So what do we multiply the measurements in with the first one to get the second one? So 5 square roots of 3 divided by 2 square roots of 3 gives me 5 halves. That's going to be our scale factor. We take this measurement times 5 halves to get the next figure. Okay. We're going to determine if these are similar, congruent, or neither. All right. When I look at them, I've got 6 and 6. That's congruent. Oh, 15 and 16. Excuse me. So this is an example, excuse me, of neither. All right. We don't have proportional measurements and we don't have the exact same measurements. All right. So we talked about scale factors with the ratio of surface area. Now we're talking about with the ratio of volume. So if your one dimension scale factor is 2 to 3, your ratio of the surface area is going to be each of those numbers squared. Okay, so 2 squared is 4, 3 squared is 9. And when we're talking volume, we're going to cube the original scale factor ratio. We're going to cube it. So 2 cubed is 8, 3 cubed is 27, right? So here we go. Two similar cones have radii of 9 and 12. What is the ratio of the volume of the smaller cone to the volume of the larger cone? All right, so the radii is 9 to 12, all right? That can be simplified to 3 to 4. And so if we're talking volume, that's going to be cubed. So 3 cubed is 27, 4 cubed is 64. That will be the ratio of the smaller cone to the larger cone. You have the rest of the time to do some practice. If you've got questions, reach out. Have a fantastic day. Take care.